All right, so let's talk about GCP. Okay, so we looked at AWS, we looked at Azure, and when you look at GCP, I would say has an edge because it came late after AWS and Azure, and it learned from the challenges that those cloud providers had, and they did things very differently, and you will notice that during my presentation, right? So let's start with the products or services that they have on their portal, right? So like AWS and Azure, when you log into the GCP portal, you see a bunch of products or services. And these are in the areas of networking, operations, there are developer tools, there are artificial intelligence, machine learning tools and whatnot, right? So that's the top level product you see. So for us, the important ones are the compute and the networking. So if you look at the compute, in the compute engine category, they have compute engine, and in the compute engine, you will notice everything that is related to a virtual machine, right? So they call their instance a virtual machine. And for the virtual machine, the things that you need, for example, the disks, the snapshot, and whatever you need is all available or bundled under this compute engine offering. Okay. Now, in the networking piece, they have, again, provided you the services from the networking point of view that an application might need in order to communicate within a VPC, or if you are going to talk to the external world. Okay. So in the VPC network, for example, on the right-hand side, you see they have the external IP address. You can apply the firewall rules. Again, you have the concept of routes here, obviously. VPC VNet peering, or VPC, not VNet, sorry, VPC network peering, and to peer the multiple VPCs together so that they can talk to each other, right? And then in the networking services, load balancer, DNS, CDN, CloudNet, we know that, right? So this is similar concepts, so like I showed you in AWS side, but the way they have implemented is obviously different, and that's what we are going to find out. Okay, so let's talk about the resources and how they are grouped. So they have a concept of global, regional, and zonal resources, right? So the global resources are the ones that are accessible across the globe. You know, anywhere you are in the globe, you can access this global resource if it is global. For example, VPC, and this is, I would say, very different than AWS and Azure, because the VPC is now global. Remember, in AWS, when I was showing you the slides, VPC was part of a region, not the case here. So they make it global, and that means the routing is also global, right? Which is a huge deal in my opinion, because if I recall back then in Cisco, we used to have technologies like OTV. Then VXLAN came in to have this overlay network that can cross multiple data centers. And now we have Geneve and other flavors. So they have done it for you. They have done it for the customers. Like, okay, if you want the global VPC, global routing, here you have it. It has its own advantages and also disadvantages, because think of it like if you have two resources sitting in two different regions, one is in the Asia, second is in US, and do you really want that, right? Some enterprises, they don't, right? There are compliance issues, there are GDPR, there are different type of issues. But yeah, but that's how they have created their underlying infrastructure, and they have given you this flexibility, right? The regional resources are obviously part of a region. So on the right-hand side, this is global scope, and then this a box here, light blue is region, US Central, right? So within the region, then they have certain resources. And then there are zonal resources. So the zonal resources are basically the virtual machines, right? So regional, the example is the subnet itself. Okay, so that's regional. And the virtual machine is zonal. But in AWS, if you recall, there is a subnet to AZ affinity, right? So the subnet was zonal concept there, but not here. Okay, so yeah, this is where a lot of my customers, they say, I don't want to go into the business of learning all that. You just give me a normalized control data and management plane where you take control of it and you worry about it. I just want my applications to work and provide the business benefits that I need. But anyway, so this is how they have defined it. Now, if you look at these resources, how they are grouped together. Okay, so this is something again very important to understand. Let me annotate so that I can show you. So if you look at this diagram on the right hand side, in the bottom you have your resources: compute engine, virtual machines, storage, networks, whatever, right? And all these resources are grouped into this thing called project, right? So this is a project layer. And in fact, when you log into the GCP portal, the first thing that you select is the project, and everything that you create is actually under the project. So you can create multiple projects based on different business requirements. For example, in this case, they have a dev project, the test product project, and then the production. And then you can create and can make it a more formal approach here, which is typically found in the enterprises, is to create something called folder, right? You can call it anything, but GCP calls it a folder. So you now have option to create or club these things into a folder, and these folders could be nested. So you can see there is a department Y folder here, and then they have different teams, and these teams, they have a product, and then this product is a test product, and then they are basically defining the application here down here, right? Yeah, and then on the top you have your company. Okay, so xyz.com, and that's your top level domain. So that's how they have grouped the resources together in a project concept. Okay. Now, if a project needs to talk to another project, by default, it cannot unless it's a shared VPC, or you provide some level of VPC peering, right? Because yeah, that's what it is important. Okay, so this is the example for the in a GCP global VPC example, the blue box here. And then within this VPC, you can see they have US East, US West, and in there is a subnet, right? This is a regional resource. Okay, and then this virtual machine you can see is part of a zone, US East 1A in this case. So yeah, so you have this VPC, you have your subnets. Now they can actually talk to each other because they are part of the same VPC. So there is a router running behind the scene, right? So they call it implicit routing. It's happening. You don't have to worry about it. You don't have visibility into this, but yeah, we will do it for you. Now, if you want to connect these subnets to the outside world, you can use VPN gateway. They provide this construct there, right? So they will build or allow you to build a VPN or IPsec tunnel to your on-prem router, a firewall, or anything that can support IPsec, standard IPsec, right? So they provide you that. And if you want to go out towards the internet, yes, they have option for that. And but they don't have any concept of public or private subnets. So as long as you have a public IP configured on a virtual machine, you are allowed to go out. So they have a concept of IGW that you also see in the UI. So that's how they actually route towards the internet. Okay, so the concept of VPC, like I said, is very different. It's a global resource. So they provide you this global routing. All subnets, irrespective of regions, they are inherently routable within a VPC. You don't have to do anything. And this is not like case like other cloud. In traditional VPC, like AWS VPC, subnets and VPCs are regional. So this is very important to remember, because that can actually dictate a lot of design decisions that you will take. And again, this is where Aviatrix is helping a lot of customers, because they don't have to worry about this. So when we built our transit network through our gateway, we provide you this normalized data plane, consistent data plane that you can repeat without worrying about all these nuances in these public clouds. Okay, so now when it comes to creating the VPCs and the subnets, you can create these subnets in two different modes. So one is the auto mode. So this is the mode which is enabled by default. So when you create a VPC subnet, GCP will automatically create subnets for you in all the regions, right? So, and this is not the best practice. GCP wants you to delete those auto-created for and then create your own custom. Okay, if you want to use the auto, there is no harm in it. But for the enterprises, if you read their enterprise best practices document, this is what they recommend you. But for a lot of customers in the SMB space, I think that's auto is perfectly fine. So when you are creating this subnet yourself, and this is what we also recommend our customers to do, you will see a mode called custom here. You will be able to specify your own IP address range. This is a subnet you create, and you will also see, global routing is the option there, which you can turn on and you can turn off, right? Okay, let's talk about the routes in GCP. So very similar to what Azure provides you, they have the option to create your own routes, right? Your own static routes. You can do the same thing here. Same thing is possible in AWS also, but they call it different. So here, the routes that are created by GCP for you are called system generated route, okay? So when you create a VPC, you will see these two routes created automatically. One is the default route, and the default gateway for this guy is the IGW, their GCP IGW, and obviously you can remove it. And a lot of enterprises will remove it if they don't want connectivity towards the internet. And then they have these subnet routes, right? These are the default one. And you have option to create your own custom routes, like UDRs, user-defined routes. Now within this, they have a static routing option, right? So if you look at the VPC network, if you click on it, you can see on the right-hand side, I'm showing you a screen to create a custom route. So you are specifying the network name, the destination IP range, and then you can also specify the next hop. So in my case, I'm specifying the instance as my next hop, which is Aviatrix Transit Gateway in this example. Okay. Yeah. So for the dynamic routing, when it comes to connecting your on-prem to GCP, you will need some sort of a dynamic routing there, right? So BGP is the only protocol that is supported, and that's actually common across the globe. No one supports OSPF. BGP is the standard in cloud when it comes to dynamic routing. So you can use the cloud router. This is the concept that they have in the GCP. You can use the cloud router to create those dynamic routes, and this router is responsible for providing only the control plane, right? So there is no data plane in this router. And this is also very important to remember that in GCP, the routing table is actually maintained inside the virtual machine. So there is a GCP managed process running in the virtual machine that will install these routes. So those are basically host routes that you will see in the GCP virtual machines. So they actually are doing it very differently. So this cloud router is the concept when you are connecting your GCP to your on-prem and you are exchanging routes through BGP. You will use this concept, but this is only providing you the control plane, okay? So this is what it is, and this is how they do it. Okay. Now let's talk about the transit, because you will see a common theme here. And the theme is that your transit basically becomes very important when it comes to building the networking and security infrastructure in the cloud. The transit is the piece that you have to be really careful about, because this is where everything will connect. This will become your cloud backbone, okay? So that's very important. And every cloud is trying to give you some features or services to solve this transit problem. In GCP case, what they're saying that, our VPC is just global VPC. You don't really need transit. So they are basically preaching you to use single VPC, but we know as enterprise IT architects or admin that we need to have different VPCs because we need to create multiple networks so we can segregate the applications in a way that enterprise needs and then provide the security and governance and then all the constructs that we need around it, right? So yeah, but they actually have this concept of VPC peering. You can do that. It's the same qualities as from any other CSP, the cloud services provider, AWS, Azure. And when you connect two VPCs together, they are actually programmed. The routes are automatically programmed, right? So you don't have to announce manually. Okay. But you see this last line here, non-transitive. This is a problem because remember I mentioned it to you before in AWS case. If you have three VPCs, on the left you have VPC A, in the middle VPC B, on the right VPC C. The A cannot talk to C because the B in the middle is non-transitive. It cannot do the transitive routing for you. So you have to create the full mesh. Yeah. Okay, so that's what it is. Now let's talk about the cloud interconnect. So the cloud interconnect is a private circuit or lease line that you can purchase from these providers like CenturyLink or Equinix that will allow you to connect your on-prem data center to GCP in a private way. So it's not going over the internet. It's a private circuit. Right? But the problem here, like other cloud, it is not encrypted. So when you purchase this cloud interconnect or express route or direct connect, it's not encrypted, right? So in case of GCP, when you go to their portal and you are about to order the cloud interconnect, this is what you see, right? So this is their dedicated interconnect, and you can select the location you're in. For example, I am selecting San Jose Equinix location, and you can see they can give you the speed of 10 gig or even 100 gig, right? So that's what it is. Or you can buy the bundle. You can say I need 2 10 gig or 3 10 gig and whatnot, right? So this is their dedicated interconnect option. But what about the customers who are not looking for that high speed? They can actually go with the partner interconnect. So the partner, if you go through a partner, they can actually provide you speeds lower than 10 gig. Okay, so these are the two type of options they have. So let's take a look at the dedicated interconnect. Okay, so we already discussed that. It actually enables you to connect your existing network or your on-prem data center to GCP VPCs through a highly available, low latency enterprise grade connection. And if you look at this diagram, so let me annotate again. So on the left-hand side, this box that you see is your Google GCP cloud, okay? And here you have your project, and we talked about the region. So, and then within the region, you have compute resources. Now you are about to connect this to your on-prem data center, which is this box. So yeah, so you need the high throughput and everything. So you go to Google and you say you order the circuit like I did in the previous slide. So you're ordering the circuit and through Equinix, for example. So you will see this guy in the middle. That's your CenturyLink, Equinix, AT&T, Verizon, and whatnot. They will provide you the circuit. So they will give you all this connectivity where you will be allowed to connect your on-prem to their location, the colo facility, you can call it. And then this colo facility will have a wire or circuit going into the Google router there, could be just a cross connect. And then that's how you actually connect to the GCP cloud, right? So this middle piece is not yours. So this is someone else's thing. And I remember I told you this link is not encrypted. So you have to trust this guy. Obviously you trust your own data center and you're also trusting GCP. That's why you're putting your workload there. But now you have this guy in the middle that you have to trust as well. I wanted to show you how actually it looks like in the UI, because we talked a lot about all these services, all these features, all theoretical knowledge, but it's important that you also see the UI so that you get familiar with, how things are clubbed together or how the resources are being organized in one way or another. Let's just start with AWS because this is the first cloud we learned about. So when you log into AWS console, you land on a page and then you see this, the services screen, right? This is your entry into the AWS console. Now in this screen, you see various services: compute, blockchain, storage, database, Internet of Things, everything, right? So for us, the most important thing as a network and security engineer, as an architect, is the compute and then the networking, which is here, down here, right? And even within the compute, the EC2 is the only thing that, at least I normally just go to EC2. I don't really worry about all these other options. In the storage, remember I mentioned they have the most popular S3, and this is what I used. And then they have other options as well, okay? So there's a lot. In the networking space, VPC is your go-to place. Pretty much every day you will be checking into VPC or doing things there. If you are staying with AWS, if you're using the Aviatrix controller, for example, or Aviatrix platform, then you don't have to worry about all these underlying details about networking and security. You have this normalized control plane, management plane, where you define things, you configure things, and then we'll do everything in the background automatically within the cloud or across the cloud, right? So this is how it looks like. Now VPC, I said this is the most important piece for networking and security guys, and in here you can see you have the concept of subnet. We discussed that, the route table, the IGW internet gateway, right? And then in the security groups is basically stateful security groups that you can specify to an instance. And then you have the NACLs, these are stateless. The CGW we discussed about, the VGW is there, the transit gateway, this is AWS, TGW, right? And you can see different routes there. You can actually go look at the routing table and whatnot, but that's it. It does not show you anything beyond that. Okay, and we also discussed about all the limitations. Okay, so that's AWS. So the second piece that we discussed was the Azure. And when you log into the Azure portal, this is how it looks like. So you might land into this one or this one on the dashboard, depending on how you have configured it. So yeah, so you can see all the resources here, right? So everything pretty much. And what Brian mentioned is that they actually club everything in a resource group. So you will create a resource group and every resource will go under a resource group name. Virtual machine is a resource, the network card is a resource, IP address is a resource. So yeah, so you will see all these options here in the networking disk and then all security space, right? So that's a very quick overview of Azure portal. And the last one I wanted to show you is GCP. So that's how the GCP or Google Cloud looks like. So when you first log into GCP, you have to select a project, because remember, everything starts with a project in GCP. So you come to your project, and when you're here, this is how it looks like, right? That's their entry dashboard. So the project info, the compute engine, and all those details. So for me or for us as a network engineers, these are the important things: the VPC network and the compute. And if you want to connect to the external world, then you will go into the hybrid connectivity option, right? And this is where, remember, I showed you the Interconnect, their dedicated private line option, the dedicated Interconnect, and also the partner Interconnect. So you can actually order it from here. In the VPC network space, this is how it looks like. If you recall, these are all the default subnets that GCP created for me. And you can see the mode is auto and the name is default, but you can also create your own subnets. So in this case, I have this transit VPC created for Aviatrix transit gateway. And then I have GCP spoke VPCs or VPC networks for the Aviatrix spoke gateways, right? So that's how it looks like. You can obviously create the firewall rules, routes, and obviously we cannot go into the details here because this is what we discuss in our professional bootcamp, and we have labs where you actually deploy these routers, these gateways, and then you play with the firewall rules and whatnot, right? So that should give you a good introduction into the world of public cloud networking. So this is where I would like to stop. And the next we have is basically a 10-minute break. And when we come after the break, we will take a look into MCNA, multi-cloud networking architecture. All right, thank you. We'll see you in about 10 minutes.